the user gives a request to the DBMS, and then the DBMS sends it to the database and proceeds to do whatever the request asked to do. So some requests ask to return some relevant data back, while others let the user put some new data or post some new data into your database. There are two types of DBMS models. One is called relational, which uses SQL, and one is a NoSQL model. MongoDB is a NoSQL model. We'll talk a little bit more about what that means, or you could just ask me at any point later on. So why do we care about databases? Quite simply, they're a very nice way of storing all of your data. They're very reliable. You can always trust them to, you always understand what is going on with them. It's really unlikely that they'll have unexpected behavior. They're optimized for handling large amounts of data. They're very flexible. And as I said, they're optimized for handling large amounts of data, so they're very scalable as well. What are some types of DBMS you could use? Well, there are quite a lot of suggestions out there. These are just some of them. And I would encourage you, with this many suggestions, to do a bit of research into what database is best for your application. So that's really all I have to say for this presentation. In the next one, I will introduce MongoDB and hook up Capbook to your new MongoDB database. Okay. Wait, really? Oh shit. I'm so sorry about that. Okay. Just do the exact same. Oh my god. Wait, it's definitely it's like. That's the right one. All right, go. Oh my god. Look at my screenshots. Cool. Do you want to do it again? Raise your hand if you actually, raise your hand if you got what happened. What was that like? All right. Raise your hand if you want to see it again. It's actually. Okay. Does anyone have questions on that picture?
Did you just show the last slide?
Just the last slide. Okay. By the way, we will be posting all the slides. Yeah. What? Oh.
You had more slides after that.
Huh? After this one? Well, I mean, wait, this is the end of this presentation, isn't it? Yeah, there's more.
That's the wrong slide. You didn't get to the slide.
Wait, I did? Oh, well, I did get to the slide there. Sorry.
Yeah,
sorry about that. Okay, so what was the last slide that we saw? This one?
This one.
Okay, awesome.
Yeah.
Okay. Does anyone have any questions about this? I know this is just a lot of terminology thrown at you guys. So
I wouldn't worry about the difference between NoSQL and SQL databases right now. In this class, we're going to be using a NoSQL database. And beyond that, if you're interested, you can do more research on it. But we're just going to use a NoSQL one. There's slight differences. If you're interested, go look it up.
Okay. I guess the primary difference is that a SQL database is significantly more structured, since everything is kind of in the format of a table. Whereas a NoSQL database, the data is a lot less structured, which gives you a lot more flexibility. So yeah. But anyways, why do you need a database? But this time with the presentation up. So as I mentioned, databases have a lot of great features that really help your project handle large amounts of data very well. And you don't have to store any of that data like on your own computer. It's there in the database. You could get exactly what you want, and it will generally work in a very optimized fashion. So anyways, what are possible DBMS you could use? Because you guys didn't see this, I'm just gonna like show the actual slides so you can see all the pictures. These are just some of the possibilities. There are even more out there of possible DBMS systems. So if you're going to do an application with a lot of data management and data manipulation, I would strongly suggest to you look up or do some research on these possible options. But yeah, that's a rerun of the end of my presentation. All right, questions, anyone? By the way, like I'm only wearing a contact in my right eye, so like I really can't see on my left. So like, it might take me some time if we're like over there. Yeah. All right. I think we're good. All right. Workshop time. So it looks like everyone got the lecture as well. So that was also really quick, so I won't be giving a break. I'll probably give a break at some point in the middle of this lecture. Anyways, so yeah, we're going to be learning about MongoDB, which is a type of NoSQL DBMS. Why do we want to use MongoDB? Primarily, I think the biggest reason to me is that it's pretty easy to learn, and since it's NoSQL, it's also much more flexible with data. In particular, these things called schemas, which I'll talk about later, can be readily changed, and using NoSQL gives us this sort of flexibility with schemas, which I'll talk about later. So what does a MongoDB database kind of look like? You could sort of think of a MongoDB instance as a large storage unit, just a large field, so to speak, of many garages, where each individual database is a singular garage. Within databases, you have these things called collections, which are like the boxes within each garage. And generally, when you put things in boxes, you want the things inside each box to be pretty similar. So for instance, like maybe that box was full of screws. So an individual document in a collection would be a screw inside the box. Finally, each document has fields or properties that we care about. So these are some possible fields you could have if your document is a screw, so like the thread, the length, and so forth. So to sum everything up, a MongoDB instance is a bunch of nested boxes in which the instance contains many databases, which each contain collections, each contain documents, and the documents each have fields. So now that we know about what MongoDB is, we probably should learn how to actually use it. So first, we're going to set up your first MongoDB cluster using a tool called Atlas. So Atlas basically allows you to connect to your database from any server, and it's free. So we're all going to sign up for it today. All right, guys, everyone, let's sign up for Atlas. Okay, is everyone online? Okay. All right, does anyone need more time right now? Okay, okay. All right, so if you scroll down to the bottom of the page, you'll see something, you'll see like a side that says get started for free. I would like everyone to fill that out. Yeah. So, and once you fill that out, click on get started here. It'll take you to a page, and then on that page, you should probably see a pop-up. The pop-up looks something like, welcome to MongoDB Atlas, your name. Does everyone see that? Okay. And click on build my first cluster. At that point, they'll ask you to choose a cloud provider and a region. For our purposes, we'll just be using AWS and Northern Virginia. That allows you to access Atlas for free. All right. Is anyone like not seeing this page? Anything unusual going on? Okay. Awesome. All right. So you should click on a green button on the bottom. It's like, I believe it says build cluster or something like that. But at that point, it'll take you to another pop-up in which it'll ask you what do you want to use Atlas for. For our purposes, we'll be using this to learn MongoDB. All right. Did everyone see this? No. Okay, that's really interesting. Huh. All right.
Okay, raise your hand and we'll come help you.
It is possible that a lot of you guys might have just gone directly to the next page, which looks, which looks something like this. Okay, did a lot of you just get this instead?
Yeah.
Okay, then you guys are fine, don't worry about it. Okay. All right, so going back a bit. After you've selected your cloud provider and your region, you have officially created your cluster. Yay! All right. Anyways, we'll be doing the rest of these steps together just to make sure everyone's on the same page. First, we'll be creating a database user. A user is any sort of entity that is able to access this database. In our case, for Catbook, it is the Express server that we made in the previous workshop. So to create a user, go to your main page and click on the Security tab. Okay. The first tab under Security should say MongoDB Users, and click on Add New User on the right. We're good? Okay. So choose a username and a password for this user. It doesn't have to be secure at all. Also, there's some of these. There's some people. Okay. So for your username and password, you don't have to choose something any particularly secure, but please choose something memorable because you will have to fill in your password later. I don't care if your password is like password.
Yeah,
Like,
a lot of favorite passwords.
what? You aren't? What? You aren't?
All
Wow.
your favorite passwords.
Interesting.
My password is user though. So it's
Yeah. You could do that.
user.
But yeah. Okay. So some people are getting help right now, so I'm gonna wait a little bit. Okay, so I think Alex down there chart.
Yeah, I must pay for it.
You want this?
Are most people good at this step right now? Most people? Does anyone still need help? Like, please raise your hand. There are a lot of steps to this, and I don't want like people to be like significantly behind. Okay. So, so for user privileges, select at least read and write to any database. This allows you to, well, read and write to your database. So put data in it, get data out of it. Okay, and then you could add your user. The next step in the setup is whitelisting your IP address. So the third tab of security is IP whitelist. Basically what whitelisting does is that it allows the whitelisted addresses to access your database as long as they have the user info. So if we click on IP whitelist, for simplicity, we'll just all allow access from anywhere. So everyone click on allow access from anywhere, and it should automatically fill out with the 0.0 point, that thing. Is everyone good? Oh, yeah. If you're stuck at any point, just remember to raise your hand and someone will come help you. And then you confirm these whitelist entries. Finally, the last step is to connect to the project. Spoiler alert, this allows your project to be connected to the cluster. It doesn't like magically do anything in which like all of a sudden like your cat book that is like up right now will say, oh, I see a new database. Like that will not happen right now. So like just in case you're expecting something like that to happen. But anyways, go back to your overview tab and click on the connect button on the left. Are we good? Okay, so you should be taken to a pop-up that looks like this. On the first page, click connect to your application and click on that and it'll automatically take you to the next tab, I believe. On the next tab, click on short SRV connection string and copy the SRV address. This address is really important. Keep it somewhere, like put it in your notepad, like write it down. Just make sure you actually have this address written because we will be copying and pasting this a lot. So it will be really sad if you have to go back and find this every single time. Right, does anyone need help with anything? Okay, I think we're good. All right, I trust that you guys have all copied this down. So a bit more about what an SRV address is, which is the thing we just copied down. When you created a cluster using Atlas, you actually created 3 different servers. The SRV address is kind of like a joint address that these servers, that point to all 3 of these servers. So in an analogy, it's kind of like a storage unit address where the servers are the individual garages in that storage unit. And with the address of the storage unit, you could figure out the address of each individual garage. The SRV looks something like on the bottom, which is the thing you just, the thing you just copied should look something like that. Where the first part on the left consists of credentials, and the right side after the @ is the storage unit address. Note that the credentials have the word password in like brackets. Please replace that entire string with your user password, including the brackets. This is why you needed to have a memorable password. And note that admin is just the name of my user. Your should be like whatever the name of your user is. So if your user is like user or something, that is what it is. Don't change the first part of your string to admin. That's just what I named my user. All right, is everyone good? Okay, all right, no hands raised. All right, did anyone have any like questions about that entire process? Should have been pretty straightforward, I think.
Again, if you guys missed any steps, feel free to, the slides should be on the website, so you should be able to step through them on the website.
All right, so that's it. So now that we have Atlas set up, we're gonna talk about what allows your app to actually interact with MongoDB. What we'll be using is Mongoose, which is a Node.js library that allows MongoDB integration, which is just a fancy way of saying it allows your application to interact with MongoDB. So what does Mongoose do? It does quite a few things. Firstly, it allows you to connect to your cluster, the code of which we'll cover in our workshop. You can also create documents, which are like the pieces of data that you put inside your database, like the screw I talked about earlier. And you could also interact with the database using get, post, so like getting information, posting information, editing, deleting, basically anything you would want to do with your database. So I mentioned that Mongoose allows us to create documents, and I also mentioned schemas way earlier in the presentation. But but they're very connected in that the way Mongoose allows us to create and manipulate documents is through schemas and models. At a high level, what a schema does is it allows us to structure Mongo documents. So you could say you expect a document to have certain fields. In the example of a screw, you would probably expect some fields to be like the length, the tensile strength, and so forth. You could also place restrictions on these fields. For example, you could specify what type these things are. So like for a lot of the measurements on a screw, the type will be a number. You could also specify if it's required, maximum, minimum values, and so forth. Each collection you have in your MongoDB instance should have a schema associated with it. This allows you to easily identify what sort of data inside and also helps your organization. So, wait, what? Okay. So I mentioned that in a schema you could indicate what types certain fields are. This is like the only required part of a schema to the best of my knowledge. And these are all possible types you can specify a field to be. You can read more about these types in the below link. You could probably just do that after lecture when we release the slides, as it's not particularly important right now. So what is a model? You have a schema which sort of like provides a frame of what your document should look like, but a model is what actually lets you do things with that frame. The models could let you create documents that fit the schema. You could get documents that fit the schema, post documents, blah, blah, blah. Anything involving the documents that fit the schema that you specified. So here are a bit more links to learn about the parameters you could use in schemas and models, if you're interested. Yeah. Okay. Should. This will be. Okay. All right. Did anyone have any questions about that last part? First and foremost, don't worry if you don't know how to code anything. I know I did not show you any code at this point. We'll be working through code through this workshop together. So that's where we will learn. Any questions? Okay, awesome. So we're just gonna like jump right in. I like lied about giving you guys a break. But all right. But anyways, so we're gonna start on our Catbook workshop, workshop 3, in which we're gonna hook your newly created Atlas cluster to your app. So just to like review, just to like quickly overview what is going on in this workshop, we're gonna be hooking up our backend to the database, and we'll be letting our front end use the implemented back-end functionalities that interact with the database as well. So by the end of this, you should have an application that is able to fully interact with your database, from making the request to displaying the results in Catbook itself. All right. Go clone the code base, everyone. Throughout this entire workshop, if you're having trouble with any step or trouble understanding any concepts, feel free to work together. And also, feel free to raise your hand, use the questions document, and you could also use this resource, weblab.2/Mongo snippets. Most of this was made by Robert Grunevander, who is now sitting in the audience. Yeah, it's actually great. I understand so much from the snippets. But these are just pieces of sample code that you could look at to get an understanding about how Mongoose works. And feel free to just look at them and use them as you work through various parts of this workshop. Yeah. Is anyone not done cloning the code base, or like not, like still wants to look at the snippets, whatever? See, like my left eye is really borked, so like literally I turn around and I see like 100 hands go up this way. It's like, sorry. All right, so it sounds like we're good. We're gonna start with step 0, which allows your app to connect to MongoDB using Mongoose. So everyone, check out step 0. And run these following lines. If anyone has any issues installing Mongoose, please raise your hand and someone will come help you. Is everyone good? Good to go? Here's some murmuring over there. Right. If you're not ready, just raise your hand. Someone will go help you. All right. All right. It looks like most people are ready, so I'll go into the next step. I'd like work through this kind of slowly just to make sure like people have enough time to catch up. Yeah. So just a quick overview of which files we will be editing. The underlined files in Capbook Workshop 3 we will end up touching in this process. In models, we'll be creating models for comments and stories so we could post them to the database and otherwise interact with them. We will be adding database endpoints in our API so we can interact with the database. db.js is we're hooking up your app to the database, and there's one file, it's not underlined, but feed.js that basically is in the front end and calls on your back end to process and render the results of your database calls. Okay. So our first step, we'll be looking at db.js. This is very simple. All you have to do is paste your SRV, which all of you guys copied down, right? From MongoDB Atlas, in where the comment indicates you should do so. I'll talk a little bit more about what db.js, each line of code actually means in a bit. But first, copy it down. Is everyone, or at least are most people here, done copying down their SRV into where the relevant place in db.js? Huh? Wait, you're supposed to check out step 0. Yeah, okay. If you don't see the db.js, that's because you didn't check out step 0. Please check out step 0 and install mongoose. npm install -- save mongoose. Okay. Does anyone need help right now? I could just like interrupt a bit. Okay. Oh, that's a code snippet. It's like that's the yeah, that's the wrong one. Okay. So okay. Got it. So don't worry. Got it. Okay. Alright, so I have to like go faster right now. So, alright. So if you're still stuck at any point, just raise your hand. There are a lot of staff who are going to help. So, yeah, once you paste your SRV in, you should have a line that looks something like this. Mongo URL equals your entire SRV. With the password replaced with your password. So before I go into this, I'm just going to talk a little bit about what the db.js file should look like. So first, the first line says required mongoose, and what that basically means is that we will be using mongoose. The next line gives you the URL, the SRV of your cluster. Then there should be a line that I believe the next line after that actually connects your db.js to the database using the SRV address. After that line, a line that says, like, mongoose.promise equals this.promise or something like that, or maybe it's flipped around. We will talk about promises much later in the class, or you can learn about them yourself, but do not worry about that. Finally, at the bottom of the file, there should be some handlers that basically indicate whether your connection was successful or a failure. So now that that is through, let's run npm start from your directory. You don't have to open up like Catbook in the browser, I just want you to run this in the terminal, and I want you to tell me what the terminal like outputs. What did your output look like, anyone? Yes? Okay, did it like print out anything after that? Okay, so if you look back at your db.js, as I said, there are two handlers. One of them handles if you connected successfully, and the other one handles if you had an error. And in each case, the console should log something. And since it's in the backend, it should be logging in your terminal. However, nothing got printed. Why did that happen? Well, that's because we actually aren't running db.js from anywhere. When we npm start, you're running the app. But your app doesn't know that db.js suddenly exists now. So to make it know that db.js exists, add the line constdb, the line that's like in the center, to your app.js under the line that requires the views. If you do this and you run npm start again, you should get a database connected message. If you don't see a message or you get an error connection, please raise your hand and we can try dealing with it. All right. So there's a lot of this workshop left, so I'm going to go a little bit faster. I'll probably just like say fewer things, but I'll probably still give you a lot of time to actually run it. There's quite a lot of people. Yeah. Okay. Okay. So are there a lot of people like still not ready right now? Is like, okay, awesome. All right, so that's step 0 for you. The next step is we'll be creating our own models. So if you're not yet done with step 0, you could just kind of like do the same thing later on. In particular, you'll be pasting your SRV address at every step except step 1. So don't worry about doing that again. Okay, that's a typo right there. Please, alright, so like check out step 1. So check out step 1 as opposed to step 2. Okay. Yeah. By the way, like checking out onto these different branches, they put everyone on the same page. So if you couldn't get the code to work in the previous step, but you basically understood what was going on at a higher level, you could just check out to the next step, and you could always just work through these steps later on when we publish the slides online. And you could always go to office hours to ask us for more help. Alright. Okay. Again, this should say step 1 and not step 2. So please reset hard and check out step 1. Are we good? Okay. So we're gonna create 2 models. The first one is gonna be for the story. Basically, we want to create a schema and a model for a story that contains the creator ID, creator name, content, and each of these things will be a string. Does anyone have an idea how we could do this at a high level? Don't worry about like implementing yet. I'm just going to show you the code once like someone gives me this like high level idea or enough time passes. I Ideas, anyone? All right, last call. Yeah, kind of like that. But basically, you just want to define the types of these parameters in your schema and create a model based on that. So yeah, we're using schemas and Mongoose models. But yeah, we're gonna like go through story.js together. So you should start writing the following code into story.js. The first line just imports Mongoose, which indicates that we will be using Mongoose. All right. Copy this down like directly into story.js, which should be in the models folder of your SRC folder. Okay. The next set of lines defines the schema. So to create a schema in Mongoose, you create a new Mongoose schema object that kind of looks like a JSON, as this audience member said. So as we mentioned, we want creator ID, creator name, and content, so we just define those as fields in our schema and define each of their types to all be string. Again, just copy this down directly into your story. Finally, once we have the schema written out, we could turn that into a model and we could export it so our API and other files can use these models. So to create a model and export it, you just say module.exports equals mongoose.model, where the first parameter is your model name and the second one is the schema that you're using with this model. Are people mostly done typing? No. Amazing. All right. Yes? Okay. Okay. All right. So yeah, this is what a story model looks like. And now, you should be ready to write your own comment model. So based on what we just did in story.js, I would want everyone to open comment.js, and I want you to create a comment model that has creator ID, creator name, parent, content, all of which are strings. Remember to export your module at the end. If you have any questions, turn to the person next to you, ask our staff, or check out.
Oh, yes.
Or check out some sample code at this link to help you with implementation. I'll give you a few minutes to just like type this out. If you have any questions, just raise your hand or use the questions document. Okay, so someone in the audience just asked me to kind of explain again what a model is and what our model is supposed to do. So I'm not sure if you want like a super technical definition because I cannot give you a super technical definition, but sort of on a more intuitive level, a schema is a framework as to what you expect a document to look like, and a model basically allows you to use that to do things with your database. So for example, your story model allows you to create story documents. It allows you to get story documents. It allows you to post story documents, and so forth. And what I mean by getting and posting story documents is that like you'll interact with anything that fits what the schema describes this document should look like. Yeah. Alright, so a few minutes have passed. I'm just going to move on to the next page, but ask any questions in the document or go to office hours, so forth, so forth.
You will also cover this tomorrow.
Yeah.
We'll do a full, on my workshop tomorrow on authentication, we also, if people are still confused based off the feedback, we'll go over it again.
Mm-hmm. Yeah. So the solution to comment.js is just as follows. As you can see, it's very similar to the solution in story.js. Again, you're using Mongoose. Your schema looks the same way. It's just that now it has an extra parameter called parent, which is also a string, and you still export it. Yeah. So yeah. So that's step 1 for you guys. We're going to be moving on to step 2. In which we create some new endpoints that allow us to call on our database from the back end. So this is like starting to actually use your cluster in your app. Okay. By the way, as we're running Kappa, we'll be doing that at the very end after all the steps are done. Don't panic, that will happen. Anyways, step 2, reset hard, check out step 2, and please copy your SRV into the db.js. Actually, for this step, you don't have to do this, but it's good to get into a habit of doing this so you don't forget to do it later on. Yeah. As you might recall, your SRV was the address I told everyone to copy down. It's the address of your cluster. Okay. Anyways. All right, moving on. So our endpoints will be in APIojs, just like all of our previously made endpoints. So everyone please open up API.js in src/routes. So just, yeah. Okay. So the first thing we'll do is we're going to be requiring our models. This allows us to use the models we just created in step 1 in our API. So you already have a line that requires story.js. I would just like you to write a line that requires comment.js. Just based on the syntax of the previous line. If anyone has any questions, raise your hand. Alright. Moving on. So your line should look something like this. You have a comment variable, and it's requiring your comment model. So it should look like that. All right, so now we're going to be implementing together some functionality. The first three I'm just gonna like walk you through like the code kind of, so you know what's going on. And the last one you do on your own. So the first one, we'll be getting all of the stories. So basically, anything that fits the story model we'll be getting from the database. Oh, sorry. Yeah. Yeah. So since like we haven't written any of this code yet, I'm just going to show you what the solution is and kind of like talk you through it so you understand what's going on. And once you know what's going on, you'll be able to write this by yourself. So this is also because I'm like running out of time. But anyways, so this is a solution to getting all the stories. To explain what each part of this means, we have story.find. So story is the model we exported from story.js. So we'll be finding anything in the database that matches this story model. .find means that we'll be finding anything in the database that matches the story model and fulfills all the parameters in the open brackets. As you can see, there's nothing in the brackets, which means that we have no requirements other than that this is a story. You can also put in parameters if you want to filter more stories. Finally, the last thing in this is a callback function, the function stories. All that does is once we get a response from the database, your API is expected to send the response back to the front end. So we have res.send stories. Stories is what the database gave us, what it found in the story.find. So that would be all of the stories in the database. Yeah, does anyone have any like questions about this? Great, okay. Okay, we'll also be like talking about this one. This is a little bit different. So we'll be implementing post/story. Oh, by the way, please type this into your your /stories route, just so you like have it.
Where did you want us to take it?
Yeah.
Basically in the get request.
Yeah.
Accessing all the stories. I can point that out to you.
Mm-hmm.
So what file should we add this?
What?
To what file should we add this line?
To what API.js. And then there should be a route /stories. So yeah. Oh, what? Can I do it myself? I don't have it. I mean, I can do that. Sure. I mean, wait. I could do that. Okay. Oh God. Sorry. Okay. Are you sure? Okay. Yeah. Okay. Anyways, moving on. There should be another method in the file. It's the /story route, and we want to be able to post stories as well. Basically, whenever we submit a post on Caplook, we want to have that post in the database. So we'll be creating a new story based on the content parameter in the request. However, where do you get the content from the request? I've like never asked you something like this before, and no one has mentioned this before. Well, the answer differs based on what type of request you're making. So there are two places you can get information from a request. Where a request is kind of like what you're sending from the front end to the back end to do with the database. For a GET request, we will be using, you would be using rec.query. I think about this in terms of when I'm getting something from the database, I'm asking the database for something, so I'm querying the database for something. So, but for a post request, you would use request.body. Because for a post request, we're giving the database something, so it's kind of like, oh, I'm giving like something with a body to the database. But yeah, since we want to be posting stories, we will be posting stories with content from rec.body.content. So let's see if I could like find the actual code. If anyone has trouble finding where to write this code, or otherwise just has like trouble with anything, just raise your hand, someone will help you. What this is basically doing is that you're creating a new story, with an arbitrary ID, an arbitrary name, and content from your request.body. And this creates a story object that you could now save into your database by using newstory.save. And the function you see right there is just a callback function. In this case, all it's doing is logging an error if you do get an error from the database. Finally, for all API routes, the front end is expecting a response. So you have to send back some kind of, you have to use res.send in every endpoint, even if there are like no meaningful results to send back. So in this case, we're just sending back an empty response. Okay, so now that I talked a bit about where to get information from a request, you'll be choosing where to get the parent parameter from the request in the endpoint /comment. Has everyone found this like get /comment? Okay. Yeah. But basically there should be like a comment that says input the parent parameter here. And based on what I said previously about where to find things in requests, where do you think you'd be able to find the parent parameter? Okay. So that now that everyone has had a chance to just think about that a little bit, the answer is that since we're doing a GET request, you'll be getting the request from the query. Again, this makes sense because when you get something from the database, you're querying the database for something. So replace the input the parent parameter here with rec.query.parent. All right, so we've worked through a few things together, and you've also looked at quite a bit of sample code. Oh, okay. So I want all of you guys now to implement post/comment. So basically what you want this method to do is to save a new comment into your database using the parent and the content from your request. To get some hints as to how to do this, look at post/story, the endpoint, or look at the Mongo snippets, and based on like the comments, you should find a snippet of code that does posting. Yeah, I'm gonna give everyone a few minutes to work on this. If you have any questions, turn to your neighbors, talk to them, raise your hand, we'll like run around and help people.
Like guys, when you think about databases, so the reason we're learning about this, right, is because before we've kind of put everything on our Express server, right, it's kind of just running there and serving files. But if your Express server like dies, right, so say your computer shuts down or something like that, right, you lose everything, right, so everything goes and just like completely dies. So that's called memory, right? So your Express server has just stuff running, and when it dies, it loses everything that it's working with. Your database sits there and it always runs. So it can save all your users' information and all of your profiles and all your posts. In addition, it's large, right? So you can think about Facebook's database is humongous, right? Because everybody's profile is sitting on that database. Can you imagine if you ran all that on one computer, it just wouldn't work, right? So that's why we're adding databases, because they're a really important component to any one web app. Does that kind of make sense?
Also, another point of confusion that a lot of people didn't have it. There's something that's bad on our end that we will fix in the future, but we have there's an API.js that's in public. That one you guys are not touching. That's what the front end is doing to make GET and POST requests to our back end. The API.js that we've been referring to in this lecture is the one that's sitting under the source folder. So the directory structure is source routes, or I think it's under routes. It's under source. It's under routes. Yeah, it's under routes. There's an API.js here. Oh god, you can't read that at all. Whatever, believe it, it's in the source folder. So that's where you guys should be looking at for the rest of this lecture. In the future, we'll clear up that confusion.
So basically,
Alright, so in the audience, how many people still need more time to work on this? A lot of people. Alright, that's great. Alright, so I'm going to give a little bit more time. So right now I want to kind of like check in on how everyone's doing. So if you're done, just like give me a thumbs up or like some kind of indication that you're done. Alright, okay, a bunch of people. Alright, there's about a entire section. Alright, okay. I'll probably give like one more minute based on what's going on right now. And after that, I'll just move on. If you still have questions, ask our staff, ask the questions, come to office hours. Alright, so we'll be moving on right now. Just like, if you have any questions, just don't hesitate to ask us in some way. Anyways, this is the solution. So basically, it looks very similar to the post/story endpoint. First, you create a new comment based on the comment model. And as you can see, you're getting the parent from the request body and the content from the request body. Just to make everything really clear, you're getting the request from the front end. So like we'll be writing this up later, but what it kind of looks like in the front end is that someone clicks a button and you create this JSON and you send that to this backend APS, and that becomes the request body when you post something. Then you save the new comment into the database using .save, and you send a response back to the front end because the front end is expecting a response. All right, so there's one more thing to do. This should be much faster. We're gonna need to link our API to our app, so our app is aware of these new endpoints. So open up your app.js file. This is inside the SRC folder, the first level. And below the line const views equals require, blah, 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 add the first centered line in the slide, and after that, go down to app.use views, and below that, have your app use the API as well. Basically, your code in app.js should now look something like this, but I'm going to give you a little bit of time just to write this all out. All right. So that is all for step 2. Now we're going to move on to step 3, in which our front end can start using the database. So everyone, please reset hard. Check out step 3. Don't forget to npm install. As for recopying your SRV, please get into a habit of doing this. But this is also not needed for this step, as we will not be running Kappa until the end of step 4. Alright, so I just got news that apparently a lot of people have questions, which is totally understandable since this is like a fairly difficult lecture. So right now we're going to take a 10-minute break, and this time feel free to ask whatever questions you want. I'll just leave this up here. We won't be moving on for another 10 minutes. But yeah.
So one thing, if you guys are totally up to sync and don't have any questions, feel free to just Facebook whatever for 10 minutes. If you guys are confused and have any questions about the structure, where things are being placed, why are we doing this, just raise your hand, please. I'm happy to help. Don't be shy.
Even if you're just confused about
there.
Yeah.
Could you just go back to the last
Raise your
slide?
hand.
You have no idea what's going on, raise your hand.
Could you just go back one slide?
Go back one slide, okay.
Alright. Raise your hand. Staff is going to get
Another
you.
one.
Please let us know.
Okay, what's the question? Yes? Yeah, go ahead. You don't even know what you're confused about. Okay,
Yeah.
that's fine. Hopefully you'll understand the next few minutes.
So, I'm going to explain it. Hi everybody. If we can take a short break, I'm just going to do a 5-minute walkthrough of the steps that we've gone through and kind of try to explain some common questions that people have had. So, one common question that, after Alex kind of explained what the motivation for why we need a database is, one step from that, specifically for MongoDB, is what is a schema and what is a model and why do we need them? So, more specifically, like dictionary definition-wise, there might be like exact reasons as to what they are, but I'm just going to give you the intuition to them, and you guys, that should be enough. So, what a schema is, basically right now we have a database, and it has no structure in it right now. So what we want to do is give it some structure for the data that we're passing into it. And the way that we do that is through schema. Basically, a schema is just a document that tells the database what information it can expect to see. So, for example, for a story, you need to know the author. You need to know what the content of the story that somebody is posting is. So that is exactly what is going to go into the schema for a story. Now, from that, we were interacting with models. And we have models like this. So, right now, alright, Cynthia, can you turn the mic off?
What? Was your mic off?
Sorry. It's okay.
How do I turn it off?
Here.
What? Sorry about that.
No, don't be sorry. Alright. So, basically, the schema is going to be what's imposing structure on this database. The model is how we communicate to it. And basically, this kind of stuff is related to something called Mongoose, right here, which you guys don't really have to worry about, but it's a tool that lets us interact with a database that's in MongoDB. So, whenever you guys want to think about what the structure is on the database, that's the schema. Whenever we're thinking about how we're communicating to this database, that's going to be part of the model. So, right here is where we define the schema. Those lines of code tell us that we're going to have a schema for a story. And it has a creator name, and some content. And you also tell the database what type of information to expect. This, over here, is where you turn that schema into a model. So you're going to allow your server to interact with the database. And because you're accessing that information from a separate file, you have to use something called module.exports. If you want to know more about how exporting works, I really recommend you look at it on your own. We'll go over it again tomorrow. But basically, this is a manner in which we can access this model from other files. The file that we interact with it from is going to be API.js. Easy example to describe. Router.get/stories. So you want to get all the stories. What you're going to do is first, you need to access the models that we defined earlier. Accessing those models is as easy as importing them because we use module.exports to allow them to be exported. So this is where we import them from. So this story over here, what type is the story? Does anybody know? What type of object is this? It's a model. Thank you. Whoever yelled that out. That's exactly correct. This is the story model. This is the comment model. So, in router.get for /stories, you want to access the database, you go through the model. And that's why you say story.find. And this is all syntax that's provided by Mongoose. And you do this function. Now, a little bit of instruction as to what this function is doing. You see just a random open and close brace right there. Why it's just an open close brace is because you say, give me all your information. What that open and close brace is for specifying selectors, which will tell you, I only want some data that looks like this. Or I want maybe all of the stories that were posted by Aaron. Well, then it wouldn't just be an open and close brace. You put some more information in there. But because /stories is meant to return to you all the stories, you just have an open and close brace right there. Again, this is the callback function, and after the database has successfully responded with all the stories, they'll be right here. And that's when we send it back to the user. Now, one thing that people were confused about, which we never really explained in detail, is why do we sometimes say rec.query? Why do we sometimes say rec.body? What is rec? What is res? So, if you guys remember, every time that we are interacting with the server, you send requests. How does the server respond to you? With responses. Well, rec probably is request, and res probably is response. And that is actually exactly what it is. And this is all stuff that's set up for us by Express. So this is another reason why we're using Express, is it provides a structure for our server to easily allow us to interact with clients and set up our backend. So now, remember, I don't know if you guys remember, but when we were posting a comment earlier, we had to pass in a JSON object with some extra information. How are we going to be accessing that information from the server? Well, that's stuff that's passed in through the request. And so we use rec.body. Now, the reason as to why you use rec.body and rec.query, it depends on what type of request that you're creating. Router.get creates a get request endpoint at /user. Router.post creates a post request endpoint at /story. So if you wanted to send a new story to be created, you're going to go to you're going to send a post request to /story. If you want to get all the stories, you're going to send a get request to /stories. So now, I don't know why it's this way. Don't ask me. If I wrote it, I wouldn't have done it this way when I created Express. But it's the way it is, so we have to teach it this way. If you're doing if you're in a GET request, the information that a user passes in will be in rec.query. So think about it. GET request, rec.query. If someone's doing a POST request and they pass in some information, the way you access that information is in rec.body. So that's a very easy way to know when you want to use query and body, is if it's a GET request or a POST request endpoint that you're in. Now, let's just go over this one area in which we're updating the database, because that's very important. Somebody is posting a story, all right? First, we have to create a new story over here. And we have to create, so we say that the creator of the story is anonymous, and they have an anonymous ID, and the content is rec.body.content. Now, clearly, what this is going to do is anytime that anybody posts a story, they're going to become anonymous, and their ID will be anonymous. We don't want that. So later in this workshop, when we hook together our front end to this back end, you're going to be changing these parameters to actually reflect what somebody's user, full name is and their ID is. Or that might happen in authentication, which I will teach. So, newStory.save, that's the command that's telling the database to save this information. Then, at the very end, we just send an empty response back to the user, because the user doesn't really care about what the response from the server is, as long as it gets a response back. That's what's key here. Every time you're interacting with the server, you send something to it, and you expect to get something back. So this is just sending something back, so the user knows that the server received the information and responded back to it. So that's what this one's doing. We can explain a little bit of example of how rec.query works. So for the get comment request, if you want to access some information that somebody passed over through a get request, you access rec.query.parent. And .parent, I don't know if you remember, but we had a JSON object that was like open brace. I'm doing a finger, that's stupid. But you passed in some information that was like even worse. you had some, what information do we have? We had an ID here. Oh god. Regardless, how do you access this parent? That's exactly what rec.query.parent is accessing. So that's why you needed to call it parent exactly, because the server is going to expect something called parent. So very briefly over the file structure that we have before we, honestly, I'm not too sure if it makes sense. We might just continue the second half of this database workshop tomorrow. But let's just go over exactly what our server setup is, because our server setup at this point is complete and ready for the Catholic front end to hook into it. So first things first, what did we do? We set up our database. And the way we set up our database is we first imported this Mongoose tool that we really need, and we helped Mongoose connect to our database through this link right here. And these are all commands that we basically just copied from the internet. Mongoose.connect, setting up Mongoose. Remember how I mentioned module.exports? This is basically exporting our database. Now, next step that we did, we hooked it up to our actual server backbone, which is in app.js. That's what you do right here, is you access this DB through required DB, which basically all it does is it runs the code that's in here and hooks up our database. Now, let's go over, we briefly went over this, just reviewing it again. We construct some models for comments and for stories, and we export those models. Now, then the last step that we did is we set up some routes. We set up the route for API.js, which is our backend routes, and we set up the routes for adding stories, I'm pretty sure, and for adding comments. And we also set up the route for getting all the stories. This will make more sense after you will stare at it a little bit more, but basically we're going to spend the next workshop, or part of this workshop, which at this point I think we're going to call it for today and just let people ask questions to make sure everybody understands this, and we'll discuss it tomorrow, how to connect the front end to this back end. But basically from this point on, our back end is mostly complete. Alright, does anybody have any questions? I know people really like the doc that we have. The doc is really nice. It allows people to get questions answered instantly. The doc is really bad is because, in a way, that lots of people have the same question. And so if somebody just asks a question and I can answer, you probably are helping a lot of other people. So does anyone have any questions? Don't be shy, please. There's literally no stupid questions.
Also, this is really like the hardest part of the course, so you guys are doing great. I really believe me.
What's your question?
I think I'm getting confused with what's syntax and what's related to other stuff in the document and in the folders.
Sure. So what, at least, what specific, like, is there anything in specific that you had, or like, so syntactically, a lot of, the reason why this is difficult is because a lot of the syntax that we're using is stuff that Express provides to us. So a lot of the times you'll see syntax that seems kind of random. The reason for it is because either we're using a tool somewhere that we have to abide by whatever rules that they provided. So the two main tools that we're using at this point is Express and Mongoose. Anytime we're doing something to set up our server, that's done through Express. Anytime we're doing something to talk to a database, that's done through Mongoose. So it's going to look like crazy syntax, but basically the best way to do it is just to look up online, like Mongoose, how to update database. Mongoose, how to find a database. And the first things in Google will tell you what the actual thing that you, like what the syntax that you want is. If you don't understand the syntax, that's honestly completely normal. I still don't understand the syntax, and I've been doing this for 4 years. Any other questions? All right, I think I'm going to go over one last thing that helps for me, is kind of going over what app.js is. So app.js is the backbone for our server. Basically, this is a bunch of Express stuff that we use to set up our server, from basically just providing somebody with hello world to actually being a fully fledged website. It's the source of truth that's used when we start up a server. So, along with that, what this single source of truth needs to do is it needs to boot up our database. It needs to define all the routes that we're going to use. And remember, routes is just what endpoints that this server is going to have. And on top of that, it needs to have some error handling. So if there's any errors that happen in our server, how are we going to deal with them? All this stuff is configured in this one file. So these are some libraries that Express needs. HTTP to make HTTP requests. If you guys remember rec.body, this is the body parser. It basically allows you to just say rec.body.parent. That's what the body parser is doing. It's converting the body into JSON. Express, we're all familiar with, we're using it. We're booting up our database right here. And basically, this is setting up, this is just where we have our views, which is our HTML files. And this is where we have our routes. Now, we boot up our Express app. We parse our bodies with JSON, which is done right here. Whenever you see app.use, that's basically configuring our server in some way. So you're basically configuring our server to use body parser. This is where we define the routes. These two are very basic. It tells you if you're going to slash, or basically this is just configuring the routes further. Right here, Zach explained this yesterday, but basically every time you access a website, there's going to be files on the front end that don't change at all. The way that we refer to things that don't change at all is static files. So basically, this is where you tell Express we have static files. And those static files are all in public, which is the cat book we've been working on in the first few days. If you ever try to access a route that doesn't exist, you're going to land here, which is error 404. There's some lines in here that honestly I don't really get, but realistically, it's just configuring how to deal with error 404s. And over here is if your server ever breaks, if there's ever a problem, if you ever crash your server, it will go into there. And it will basically tell the user that there is an error. And over here, you're defining what port your server is listening on. So hopefully this helps with understanding like how app.js is structured. There's a lot to kind of understanding this server. A term that a lot of people use is black magic, which is basically there's a lot of things that you're just trusting that somebody else has gotten working, and you're just blindly using their configurations. Realistically, that's a lot of web development in a nutshell, but
Wait a minute.
this is for me. In the beginning, it's black magic, and in the end, you'll get used to it over time.
That's not
Okay,
the
you guys can understand the black magic.
Alright, so I think we're going to call it for today. If you guys have any questions, just stick around and we'll help answer them.
Yeah, staff can stick around after class, because I know this was a confusing lecture. We're going to answer your questions, so just stick around. We'll be here.